The artificial intelligence revolution appears to be led by American giants like Nvidia, Microsoft, and Google. But hidden inside a factory in the Netherlands is a machine so complex that no other company on Earth has been able to build it commercially. Without this machine, manufacturers cannot produce the most advanced chips at scale. And without those chips, the AI boom begins to slow down. This is the extraordinary story of ASML, the company quietly standing between the world and its technological future. Every artificial intelligence model depends on physical infrastructure. Behind the software are data centers. Inside those data centers are thousands of advanced processors. And inside every processor are billions of microscopic transistors. The smaller and more precise those transistors become, the more computing power engineers can place inside a chip. But designing an advanced chip is only part of the challenge. Someone must manufacture its impossibly small patterns on silicon. Companies such as TSMC, Samsung, and Intel operate the factories. Nvidia and other designers create the architecture. But the critical machines that print the smallest and most demanding layers come from ASML. That makes this unfamiliar Dutch company one of the most important links in the entire technology industry. The story did not begin inside a futuristic laboratory. In 1984, Dutch electronics giant Philips and semiconductor equipment company ASM International created a joint venture called ASM Lithography. Its first workplace was hardly the birthplace of a future technological empire. The young company operated from a leaking wooden shed beside a Philips building in Eindhoven. It entered a market already dominated by stronger competitors. Its survival was uncertain, its resources were limited, and few people outside the industry had any reason to notice it. Yet the company possessed one crucial advantage. Its engineers were willing to pursue precision problems that others considered too difficult, too expensive, or too distant from commercial reality. In 1985, the business moved to nearby Veldhoven. The obscure name ASM Lithography would eventually become ASML. As chips became smaller, conventional lithography approached a fundamental barrier. To print finer patterns, manufacturers needed light with a much shorter wavelength. The proposed answer was extreme ultraviolet lithography, or EUV. EUV uses light with a wavelength of just 13.5 nanometers. But producing that light reliably inside a factory was an extraordinary engineering problem. It is absorbed by almost everything, including air. Traditional lenses cannot guide it. The entire optical path must operate inside a vacuum and depend on some of the smoothest mirrors ever manufactured. For years, EUV looked less like a product and more like an expensive scientific experiment. ASML continued anyway. The company worked with an international network of specialists, including Zeiss for advanced mirrors and optics, and teams in the United States developing the light source. Its competitors still had lithography businesses. But gradually, ASML became the company prepared to make the industry's most dangerous technological bet. To understand why the machine is so difficult to copy, consider what happens inside its light source. A generator releases microscopic droplets of molten tin through a vacuum vessel. Each droplet is only a fraction of the width of a human hair and moves at roughly 70 meters per second. A first laser pulse strikes the droplet and flattens it. Then a second, more powerful pulse vaporizes it into plasma, producing extreme ultraviolet light. This sequence must happen up to 50,000 times every second. The light is then collected and directed through a system of multi-layer mirrors. It carries the pattern of a chip design before being focused onto a light-sensitive silicon wafer. Meanwhile, the wafer stage must move at extreme speed while maintaining accuracy measured in fractions of a nanometer. And this cannot work correctly once, inside a laboratory. It must work repeatedly, accurately and economically, day after day, inside factories producing enormous numbers of chips. ASML's achievement was not simply inventing an impressive machine. It was transforming one of the most delicate scientific processes ever attempted into an industrial production system. And the machine is not the creation of ASML alone. Its advantage is built across a deeply specialized network that has taken decades to develop. In 2025, ASML reported working with approximately 5,100 suppliers across Europe, North America, and Asia. The company itself employed more than 44,000 people. Some partners create optical components that few organizations can manufacture. Others provide lasers, sensors, precision stages, software and materials operating at the limits of physics. A competitor would therefore need far more than money and a team of talented engineers. It would need to reproduce decades of accumulated knowledge, rebuild thousands of supplier relationships, and integrate every component into a system where a tiny error can ruin the result. That is the real barrier surrounding ASML. Its power does not come from one secret blueprint. It comes from an entire ecosystem that cannot be assembled quickly. This explains why the world's leading chip manufacturers depend on the same Dutch supplier. TSMC uses advanced lithography to manufacture leading-edge chips for some of the world's most powerful technology companies. Samsung competes in advanced logic and memory. Intel is investing in new manufacturing technologies, including the next generation of high-NA EUV. These companies compete fiercely with one another. But at the most advanced edge of lithography, their road leads back to ASML. The more artificial intelligence increases demand for leading-edge logic and advanced memory, the more strategically important these machines become. The visible AI race may involve models, applications, and famous chip designers. Behind that race is a quieter contest over the physical tools required to manufacture computing power. If you enjoy discovering the hidden companies and decisions shaping the global economy, subscribe to Empire Stories and turn on the notification bell. There are more extraordinary stories hiding behind the world's most powerful industries. But ASML's position is not guaranteed by its past. The company is already pushing toward the next generation, high-NA EUV. By increasing the system's numerical aperture from 0.33 to 0.55, the new platform is designed to print smaller features with greater transistor density. The challenge is that every improvement creates new problems. Larger and more advanced mirrors must maintain extraordinary precision. Faster stages must move without sacrificing accuracy. The light source, software, and surrounding manufacturing process must evolve together. This is the strange reality of ASML's business. The company holds an extraordinary position, yet it cannot stop taking enormous risks. One failed technological transition could give competitors time to recover. But one successful transition can extend ASML's advantage for another generation of chips. This concentration of capability has transformed a business story into a geopolitical one. Advanced semiconductor equipment now sits at the center of export controls, national security policies, and competition between major powers. Governments understand that controlling access to the most advanced chip-making tools can influence who develops the fastest computers, the strongest artificial intelligence systems, and the most sophisticated defense technologies. ASML must therefore operate between commercial demand and government restrictions. It is a company based in the Netherlands, dependent on a global network of suppliers, serving customers across several competing economic blocs. Its strength comes from globalization, but geopolitical fragmentation is now one of its greatest risks. The world depends on a machine assembled through international cooperation, at the same moment that international cooperation is becoming more difficult. The most powerful company in artificial intelligence may not be the company with the most famous model, the fastest chip, or the largest data center. It may be the company that builds the tool everyone else eventually needs. ASML began inside a leaking shed, surrounded by uncertainty and stronger competitors. 4 decades later, its machines help determine how far the world can push computing itself. That is the hidden architecture of technological power. Not always the product people see, but the irreplaceable machine behind it. Subscribe to Empire Stories, turn on the notification bell, and join us for the next story behind the empires shaping our world.